M6C1 test capacitors. Question 16, which follows on from 15, which follows on from 14, which follows on from 13. Question 16, possibly the mother of all capacitor questions. So the question is, calculate the charge remaining on the capacitor at time t equals 80 seconds. And remember that at time t equals 0 seconds, the switch is flipped to position 1 and the capacitor begins charging. And at time t equals 30 seconds, the capacitor isn't fully charged. It doesn't matter. They flip the switch to position 2 and then the capacitor starts discharging through 2 resistors instead of just 1. So if we add all the pieces of information from question 13, remember at the beginning we're going to start with the switch in position 1, and then at time t equals 30 it's going to flip over to position 2. But let's start by looking at the charging circuit initially for the first 30 seconds of this question. So we'll be using the charging equation that includes the 1 minus part here. The charge is not going to be a complete charge. It's going to head towards the peak charge, but it's not going to quite get there. It's only going to be charging for 30 seconds. So in order to work out what Q0 is going to be, just like we did earlier in this sequence of questions, we'll start with the definition of capacitance, the amount of charge stored per unit potential, rearrange to make Q the subject, Q equals CV, C being this number here, 580 microfarads, V being this number here, 9 volts, and the answer to that calculation is going to form Q0, which is going to be inputted into this charging equation here. The time is going to be 30 seconds because we're only going to have the switch in position 1 for the first 30 seconds, and the resistance is only going to be one of these. There's only one resistor in the charging circuit, so resistance in this equation is going to be 40 kiloohms and the capacitance 580 microfarads. At time t equals 30, the switch moves from position 1 to position 2, and then we're going to start discharging through 2 resistors with our starting charge on the capacitor, whatever charge it got to in the first 30 seconds. Jesus, this question is so hard. So because we're now discharging the capacitor, we're going to be using the discharging capacitor equation, the charge stored on the plates as it discharges. And this charge we calculated after the first 30 seconds now becomes our starting charge as we discharge for the remaining 50 seconds. Man, this question is so hard. Right, there's our, okay, right, we've got Q0 sorted. The next thing is that what we put in here for time is not going to be 80 seconds. We're going to take 80, subtract 30, because the 30 seconds was, switch was position 1, we were charging. At 30 seconds we flipped over to switch position 2, and then we started discharging, and we're only discharging for 50 seconds. So the time in this equation is going to be 50 seconds. The other catch is that the resistance is now in the discharging circuit. There are 2 resistors and they're in series with each other, so we're just going to add those together. 40 kiloohms plus 40 kiloohms is 80 kiloohms, and this resistance value is going to be 80 kiloohms, and capacitance is going to be 580 microfarads. This question is crazy difficult, how many catches there are to trip you up. So if you can get the right answer for this question, you are capacitors expert as far as I'm concerned. So just to tidy it up a little bit, let's break it down. This is the discharging equation we're going to use to calculate the charge remaining on the capacitor after it is charged for 30 seconds and then discharged for 50. So Q0 is going to be calculated by partially charging the capacitor for 30 seconds up to a potential full charge, calculated here Q0 equals CV, but we don't quite get to that full charge, we only get a little bit of the way there, and then that becomes our Q0 for our discharging equation. The time for our discharging circuit is not going to be 80 seconds, it's going to be 80 minus 30. We're only discharging for 50 seconds. and the resistance of our discharge circuit. There are two resistors in the discharge circuit, so that resistance there is going to have to be 40 plus 40 is 80 kiloohms. Best of luck with this one.